Smart Child Zone presents Newton's Laws of Motion. Sir Isaac Newton published 3 laws in the 17th century. In this session, we are going to talk about Newton's first law. This law is an introduction to motion of the object and the force acting on it. In other words, it deals with the motion of an object and its relation to force. Newton's first law states that a body remains in the state of rest or uniform motion in a straight line unless and until an external force acts on it. An object at rest stays at rest. An object acted upon by balanced forces stays at rest. An object acted upon by unbalanced forces changes speed and can change direction. Wearing a seatbelt in a car while driving is an example of Newton's first law of motion. When a car brakes quickly, the passenger will be thrown forward because inertia, the tendency to remain unchanged, tries to keep the passenger moving. The first law explains why you go flying over the handlebars if your bike stops suddenly. Things tend to keep doing whatever they were doing before. If an object is stationary, like the puck on ice, it will remain stationary. If the object is moving, it will continue to move at the same speed and in the same direction. An object acted upon by an unbalanced force changes speed and direction. The second part of Newton's first law is sometimes forgotten. You have to remember that it applies to bodies that are moving at a constant velocity, not just those at rest. This car will never move unless pushed to start moving. This car would never stop unless a force acts upon it. These forces that reduce its speed are friction and drag. Newton's first law can describe a roller coaster. A roller coaster has inertia. When it starts a drop, it wants to continue moving in the same direction at a constant speed. It doesn't, however, because the tracks act as an outside force that changes the roller coaster's direction. The movement of a ball in a box can be explained by Newton's first law of inertia. Place a ball in a box and slowly push the box. Abruptly stop the box. The ball will keep moving. According to Newton's first law, an object in motion tends to stay in motion unless acted upon by an unbalanced outside force, so the ball keeps rolling even though the box has stopped. We put this in for fun and to help you remember the words of Newton's first law of motion. An object at rest will remain at rest unless acted upon by another force. When you bowl a bowling ball down the lane, a slick surface with little friction, the bowling ball will continue at the same velocity until it hits the pins. Because there are no other forces acting on the bowling ball, it will continue at the same velocity as you released it, not slowing down until it experiences a force that cancels out its velocity, i.e. when it hits the pins or the end of the lane. A person is in an elevator that moving upward at a constant velocity. The weight of the person is 800 Newton. Immediately, the elevator rope broke, so the elevator falls. Determine the normal force acted by elevator's floor to the person just before and after the elevator's rope broke. We are given the weight and we want to know the normal force. When the person stands on the floor of the elevator, weight acts on the person where the direction of the person is downward. That person at rest, so that there is must a normal force acts on the person, where the direction of the normal force is upward and the magnitude of the normal force same as the magnitude of the weight. Because the person is at rest in the elevator and the elevator moves at a constant speed, no acceleration, so there is no net force act on the person. Therefore, a block with a mass of 20 gram moves at a constant velocity, on a rough horizontal floor at a constant velocity if there is an external force of 2 Newton acts on the block. Determine the magnitude of the friction force experienced by the block. We are given the mass and force. What we want to know is the magnitude of friction force experienced by the block. Based on Newton's first law of motion, if a block moves at a constant velocity, then the block has no acceleration. The block moves at a constant velocity, and there is no acceleration if 1. The magnitude of friction force same as the magnitude of the external force. 2. The friction force has opposite direction with the external force. So, we apply Newton's first law of motion. Therefore, the magnitude of the friction force experienced by the block is 2 Newton. A smooth inclined plane with a length of 0.6 meter and height of 0.4 meter. A block with the weight of 1350 Newton will move upward using the inclined plane. Determine the magnitude of force needed to move the block. We can use this info to calculate the angle of the inclined plane. Based on Newton's first law of motion, the block start to moves upward, then the external force minimal is same as the horizontal component of weight. A soccer player starts at rest and accelerates forward, reaching a velocity of 8.00 meter per second in 2.50 seconds. A. What is her average acceleration? B. What average force does the ground exert forward, on the runner so that she achieves this acceleration? We are given the initial and final velocities, 0 and 8.00 meter per second forward, thus, the change in velocity is 8.00 meter per second. We are given the elapsed time, so change in time equals 2.50 seconds. The unknown is acceleration, which can be found from its definition. Change in velocity over change in time. For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.